So in this video, I'll continue my discussion of how we can use the TI84 to find area under the curve, which is what we're using to represent probability. So let's see. The first type of question that we're asking here is and again, right now we're focusing on the standard normal distribution. So I'm using z for my variable. So if I want to find the probability that z is greater than a certain amount, for instance, negative 0.47. I'm thinking to myself, okay, in a standard normal distribution, the center is at 0. Here's negative 1. Negative 0.47 would be about halfway in between these two values. And this is a question where I'm asking greater than, so that's a value to the right. So I'm trying to find the area in this shaded region. And remember I said that this goes on and on and on up to positive infinity. So I'm looking for the area that goes from negative 0.47 all the way up to infinity. So I'm using the normal CDF function, and that is found in your calculator if we go to the distribution menu by hitting second key and then VARS, and it's the second option. Distribution, second option. And if you have prompts, that's great. If not, we're going to use a comma separated list where we use the lower bound of the area, then the upper bound for the area, and then mu and sigma. So for this particular question, I'm going to use negative 0.47. And for my upper bound, I'm just going to use a really big number. My suggestion is 10 to the 99th power. And then, since this is the standard normal distribution, 0 and 1 are my mean and standard deviation. So negative 0.47, comma, 10 raised to the 99th power. Get out of the exponent position, comma, 0, 1, and enter. It turns out that this is 0.68. That's an equals, not a negative sign, 0.68. And that makes sense. Remember that from 0 over, that's 0.50. And and from negative 1 over would be 0.50 plus 0.34, so 0.84. So I was expecting an answer somewhere in between these two values. These values come from the empirical rule, and so this 0.68 makes perfect sense. If you prefer to think of that as a percentage, that'd be 68%. Let's do another. The probability that we'd get a z-score of less than 1.89. And so I'm thinking to myself, okay, where is this? So here's 0, 1, and 2. And 1.89 is a little bit to the left of 2. And I'm looking for an area to the left because this is a less than statement. So I'm trying to find all of this area. So that line right there is at 1.89. So this goes on to negative infinity. So again, I'm going to use my normal CDF function. The lower bound is negative infinity, so I'm just going to use a really big negative number. Negative 10 to the 99th will work. The area ends here at 1.89, and I'm going to use 0 and 1, and then go to the calculator, distribution, option 2, negative 10 to the 99th power, comma, 1.89, comma, 0, comma, 1, and that is 0.97, and that again makes sense to me. Again, knowing the empirical rule, to the right of 2 is 0.025, and that would mean that to the left is 0.975. But my cutoff point was 1.89, which is a little to the left. So I'm just emphasizing that two things here. First, drawing a picture is very helpful so that you can kind of keep it straight about what is your left or lower bound, what's your upper bound, and then also, keeping in mind what we know from the empirical rule as estimates tells us if our answer from the calculator is reasonable. Okay, one more. The probability that we would get a z-score maybe in between two values. Let's say between negative 2.5 and negative, or let's just do positive 0.67. So as far as the calculator function goes, this is a best case scenario because we have an exact value for a lower bound, negative 2.5, and an upper bound, 0.67, and our mean and standard deviation once again are 0 and 1. So I'll choose the normal CDF function, negative 2.5, comma, 0.67, comma, 0, comma, 1. And this is 0.74. And let's see if that makes sense to us. So here's the curve, negative 1, negative 2, negative 3, positive 1, 2, 3. So negative 2.5 is over here, and 0.67 is over here. So I'm looking at the area that extends from negative 2.5 up to positive 0.67. And it's not surprising that that's a little over half the area under the curve. And so I think that this makes sense as an answer, 0.74. That would have been a hard one to estimate because neither of these, well, I guess that this, we would know that this is roughly a half. There's very little area, this in the tail, over here. So from here over, I guess it would be safe to say that's about half. And then this is, from here to here would be 0.34. So I know that I'm not going all the way over to positive 1. So that seems like a reasonable answer to say that it's less than 0.5 plus 0.34. So I was expecting an answer less than 0.84. And again, I just want to make sure I'm clear on why I'm saying 0.84. If we use the area to the left of 0 is 0.5, and the area between 0 and 1, so just from here to here, is 0.34. Adding those two together, I get 0.84. So the area here I know is going to be less than that, and so that's why I think that this answer again, let me say that again. The area to the left of 0 is 0.5. The area between 0 and 1 is 0.34. When you add those together, you get 0.84. And so I expected this result to be less than that sum. And another possibility, I could say, what is the probability that z is less than 1.2 or greater than 1 or 2.2. So here's 0, 1, 2, and 3. 1, 2, 3. Less than 1.2. So 1.2 is a little to the right of 1. So it could be less than that. So that would be all of this area. Or greater than 2.2. So 2.2 is over here. So it could be in this tail. So it can be in either of these two places. So one strategy is to break this up into two pieces. So one where we look at the normal CDF that goes from negative infinity, I'll just say negative 10 to the 99th, up to 1.2. And then we'll look at the normal CDF for the right-hand tail, which would be from 2.2 to positive infinity. And again, I'm using 10 to the 99th for that, and 0, 1. And then I'll just add those two values together. So let's look at that in the calculator. Let's see. Distribution. Normal CDF. Negative 10 to the 99th power. 1.2. 0, 1. And so this is 0.885. And I do this a second time using the normal CDF. That's 2.2, 10 to the 99th power, 0 and 1, and that is 0.014. So I would have to add those two together. So 0.885 plus 0.014. That is 0.899. So I took the area that I have represented by this shaded region to the left and add that to this, and that answers this OR question. Now, another thing you might recognize is that the only possibilities that I'm excluding are the values that are in between, so what I'm shading in black. But if I take all that together, that's the entire curve. So I could say 1 minus, and then just look at the area that's in between 1.2 and 2.2 in the standard normal curve. And so 1 minus, and notice that in my calculator I can just write 1 minus and then go to the distribution menu and select the CDF function and say 1.2, 2.2, 0, 1, and we'll get the same answer, 0.8988. So I had just rounded before. So I want to point out that they're really just, as far as these probability questions where we're given a value of z, there are really just three questions. The probability that z is less than a certain amount, the probability that z is more than a certain amount, and the probability that z is in between two values. And for all of these, we're going to be using the normal CDF function. So let's say that this is, I'm going to just use A, B, and then A and B here. So if we want to know that it's less than a certain amount, we would use negative 10 to the 99th, that amount, 0 and 1. If we want to know that it's more than a certain amount, that amount is our lower bound, and then we can go to positive 10 to the 99th, use 0 and 1. And if you want to know it's in between, you can just use A, B, 0, and 1. Now, of course, in this OR question that I ask here, the probability that it's either less than a certain value or more, you can just say 1 minus the normal CDF. So you would just be using this in a slightly different way as a complement. All right, in the next video, I'll talk about the inverse. So what happens when you are given an area and you want to find the corresponding z-score. Hope you'll join me.